Hey guys, today we're going to do 6 rational exponents. Let's get started. So this is the first thing you need to recognize, radical and exponential forms. So we're kind of used to this format right here, where I have my nth root and whatever's inside, it might be raised to some exponent, possibly. And the index for a square root is 2, of course. So if we wanted to rewrite that as an exponent, or its exponential form, the exponent will become m over n, meaning my exponent over my index. So basically, the index becomes the denominator of your rational exponent. So keep that in mind. So here's the first example. We're going to write x to the power of 1 over 6 in radical form by realizing that the denominator is the index. So it's going to be the 6th root of x to the power of 1. I don't ever really technically have to write power of 1, so I'm just going to leave it like that. And I'm going to write this one in exponential form, so how this looks right here. So remember, my denominator is my index. So that's going to be d to the power of 7 over 2. Okay. Moving forward, let's go ahead and evaluate an expression with a rational exponent. So let's look at this. Right now, I have 81 to the power of negative 1 over 4. First of all, let's go ahead and make that negative exponent a positive exponent. We remember how to do that. Put the 81 on the bottom. So it's positive 1 over 4. Okay, there's many ways you could work this out and get it correct. So if you think you can come up with a different way, let me know. I'll check it out in class and see if that's a good way. So what I'm going to do from there is go ahead and evaluate this. So let's think about what this means. This really means 1 over the 4th root of 81. So I'm sitting here and I'm really having to consider what number times itself 4 times. I'm looking for a group of 4 to give me 81. So let's think about this. I start with 9 and 9 to get 3 times 3 times 3 times 3. So that would be 3 written out 4 times. So the 4th root of 81 is 3. So my final answer is 1 over 3. Because 1 was already on the numerator, and the 4th root of 81 is 3. Okay, let's try another one. Let's evaluate this one, 216 to the power of 2 over 3. So hopefully you're recognizing something at this point. Hopefully by now you know that 216 can be rewritten as 6 to the 3rd power. Because 6 times 6 times 6 is 213. And so this 6 to the 3rd just represents the 216, but then 2 over 3 would be for the exponent. Okay. So one thing that we learned earlier in the year is the power to a power rule. When I have an exponent inside and an exponent outside, what I can do is multiply those exponents together. With that being said, I'm going to have 6 to the power of 3 times 2 over 3. Remember how we multiply fractions? We just multiply straight across. So 6 over 3. I'm going to do this off to the side. 6 over 3, which is 2. So really I could rewrite this as 6 squared. And 6 squared just equals 36. Okay, moving on. Go ahead, take a second to try this one on your own. I wrote the answer for you, but I am expecting to see your work when I check your notes. So if you have questions on this, ask in class. I got 8. Let's look at this one here. Evaluate expressions with rational exponents. So remember, if my bases are the same and they're both a in this case, what I do is add my exponents together when I multiply. So I'm technically adding 2 over 7 plus 4 over 7. If you forgot how to add fractions, remember they need a common denominator, which they have. And I just add my numerator. So 2 plus 4 is 6. Okay. Next, let's go ahead and try this one. B to the power of negative 5 over 6. So once again, I noticed that I have this negative exponent here. So let's go ahead and take that exponent and rewrite it so that it's positive. So that would give me 1 over b to the positive 5 over 6. Okay. What we need to do, similar to how we rationalize the denominator, imagine if I rewrote this in its radical form. I would have a radical in the denominator technically. So what I'm going to do is I'm going to multiply by something to make this to be b to the power of 1. And remember what happens when I multiply fractions. I add them. When I multiply exponents, I add the fractions. So what I'm going to do here is multiply by 1/6. Because when I add 5/6 plus 1/6, I will get 6/6, which is 1 whole. But what I multiply by on the bottom, I also have to do on the top. So b to the power of 1/6 over just b. Okay, so the reason I multiplied by this 1/6 and didn't just leave it how I had it here was because imagine if I rewrote this in its radical form. If I rewrote it like this, that's kind of an illegal move. We don't want to have radicals in our denominator. So that's what this would be equal to, a radical in the denominator. So we just rewrote it. Okay, let's move on. Go ahead and try this one on your own. Okay, did you get that answer? Check it out. And then try this one on your own. Did you get that answer? I sure hope so. Ask me in class if you didn't. So here's the next part that we're going to talk about, simplifying radical expressions. When simplifying a radical expression, use the least index possible. You're going to use rational exponents and write your answer back in a radical form. So let's see what that looks like. Let's simplify this radical expression here. Notice how it looks. I have the 4th root of 27 and the square root of 3. So what we're going to do first is write it as rational exponents. So I'm going to rewrite this numerator as 27 to the power of 1 over 4. Remember, I got 1 over 4 because this is technically a 1 here, and then the 4 is my index. And let's rewrite this as 3 to the power of 1 over 2. Do not forget that your index right here is 2, but we just don't ever write that because it's implied. So let's go ahead and rewrite this to get a common base. What I mean by that is let's convert this 27 to 3 to the 3rd. I chose 3 to the 3rd because there's a 3 in the denominator. Okay. As we've done before, let's go ahead and multiply the exponents on the numerator. So that would give me 3 to the power of 3/4 over 3 to the power of 1/2. And as we've done before, whenever you divide, our exponent rule is to subtract the exponents. So it's going to be 3 to the power of 3/4 minus 1/2. So what is 3/4 minus 1/2? I'm going to do it off to the side here. 3/4 minus 1/2. I'm going to make 1/2 as 2/4. So it would be 1/4 there. 3 to the power of 1/4. And then following the steps, it said to rewrite it in its radical form. So the 4th root of 3. Okay. Finally, let's do this last one. So looking here, what I would do is rewrite this in its exponential form. So I'm going to have 4 to the power of 1/6. There's technically a 1 here. And I'm going to have x to the power of 4/6. Okay. If I can rewrite this number as a different base, let's go ahead and do that. I can rewrite that as 2 squared. 2 squared to the power of 1/6. X to the power of 4/6. We can reduce that to 2/3. Sorry guys, I'm struggling. And then finally, let's go ahead and multiply these together. 2 to the power of 2/6. X to the power of 2/3. Of course, I can reduce 2/6 to 1/3. And I can reduce this to, oh, it's already 1/3. So one thing I noticed is that they both have the same denominator, or the same index. My index would be 3. My 2 has a power of 1. I don't necessarily have to write a power of 1. And my x has that power of 2, so x squared. Okay, that's it.